All right. Hey guys, I got a couple of emails from people on number 11 on page 19 from the homework tonight. So I love those emails because if I get multiple of them, it might be worth sending out an explanation. Now, a group will be responsible for this one for the Jamboard tomorrow. So I just want to remind you that always your homework answers will be available to you the following day. So you just need to turn your work in the way you kind of have it right now, because a large part about this course is going to be kind of picking up what other people see and the way that other people kind of explain things and adding to your understanding here. You really just want to learn a little bit more each and every day, and I'll be saying more about that tomorrow. Anyways, we have number 11 on number 19. If you want to check it out right now, perhaps this could be helpful to you. Again, I heard it from multiple people, so I'm guessing there are more people out there where this is going to be helpful to hear right now. All right, let's check it out here. Quick reminder of what I told you guys last class right here. You start a proof. Remember, a proof is kind of an if-then statement we're trying to prove. If measure of angle 1 equals measure of angle 3 and measure of angle 2 equals measure of angle 4 in this diagram here, then what we can prove from that is that the measure of angle ABC is going to equal the measure of angle DEF. Do we know it's true yet? No, but there's going to be a proof written, so we're going to prove that that statement is true here. Okay, so the reason why I pointed my arrow down there is because I told you guys this on Wednesday, that you start the proof with this given here. That's sort of your if statement. If this, then that. But your if statement here is called your given premise right here. This is your given premise, right? This is your given fact dropped to you by the mathematical gods here, that we know that angle here, angle 1, is congruent to angle 3. This angle here, angle 2, is congruent to angle 4, and therefore their measurements are the same here, right? Their measurements are the same. There's our given premise. Okay, so that's our given premise. Over here, this is called our given diagram here, Using these two things, a given premise and a given diagram, we're going to show through a chain of reasoning that this fact down here, right, this right here, it has to follow, right? It has to follow from our given premise, our given diagram. We're using that in combination with one another, and then we're going to get this thing to follow, and that tells us kind of the order that we need to do things in, okay? I circle given premise up here because that's actually the very first step of the proof. About 90% of the time, given is going to be your very first reason. And look at that. We have our given premise right here, right? Measure of angle 1 equals measure of angle 3, and measure of angle 2 equals measure of angle 4. Now we got to look at what the book's doing for us here. So this is kind of hard. Sometimes it's easier, actually, honestly, to write a proof on your own to get to this proof statement right here. Because this here, let's just look at the proof real quick. This is pretty obvious, right? This angle has the same measurement as that angle. This angle here is the same measurement of that angle here. And your goal here is to prove that the larger angle here has the same measurement of the larger angle here. So it's a pretty easy proof. It's kind of common sense, right? This is going to be, this part is the same as that part. That part is the same as that part. And if the two parts are the same as these two parts right here, what's the argument we can make about the holes? Well, they got to be the same too. You're just adding equal parts here. You're adding equal parts here. And the result, the sums of these two measurements and the sums of those two measurements got to be the same, right? Because you're adding the same angle measurements in both of them here. So, right, very much common sense, but they've already put the steps down for you. So I think you could have maybe written the proof on your own even at this point, but they want you to just get used to seeing something and think about, how are they saying this? Like, why are they saying this? Why are they able to do it? So remember, we started with a given premise here. So normally when I write proofs, what I recommend is start with the given premise and think, is there anything I can do with this given premise right here to then change the way I'm writing this premise right here, to change it around and then say something else, right? And say something else here. So you might not realize why that they're doing this, but here they actually did. Like, we notice this here. This first step here led directly into this step right here. How did it change? You got to ask yourselves with your statements here, because remember, statements are kind of like where your equations and statements of congruency go. So you got to think from one step to the next step. How did it change, right? How did it change here? Well, I see I have measurement of angle 1 here, and I have measurement of angle 2 here. Well, I got measurement of angle 1 here, measurement of 2 here, measurement of 3, measurement of 4. How did it change? Okay, I'll show you how it changed here. And then again, I just with more and more practice with this, you're going to start seeing this here. Look at this, measure of angle 1 plus measure of angle 2. And that's what's on the left side of our equation right here, right? Measure of angle 1 plus measure of angle 2, they sum together. And this measure of angle 2 equals measure of angle 4. So we can, if we're adding 2 to this 1 here, we can add the 4 to this measure of angle 3 right here, and the right side of the equation would still equal the left side of the equation. Our equation would be balanced here. So what we really just did here is we took this top equation right here and added measure of angle 2 to the left, added measure of angle 2 to measure of angle 4 to the right. We added equal values to both sides of the equation, therefore preserving that statement of equality right here. So I think if you just hear me say add a whole bunch of times, I think you know what to write now. This is just the addition property of equality. Right? Addition property equalities tells us that we can add equal things to the same side of one equation and equality is preserved. Then that will result, the resulting equation will also, it still be equation, right? Will still be a true fact here. All right, next up here, we got something else here. We got something else. So at this point here, we got this, and that's important, right? Because we want to get this angle plus that angle equals that angle plus that angle. And that's good, right? That's good because we want to show that the whole and the whole are equal to each other, right? This is sort of what we want to show as what we're trying to prove here. Angle ABC is right here, and angle DEF is right here. And our goal here is we want to show that these measurements have to be the same. So 1 plus 2 and 3 plus 4 being the same, that's really, really helpful. But have we said yet that measure of angle FED and measure of angle ABC are equal to each other? No, we haven't said that yet. We got to be able to justify it here. So here's basically where I'd look at this, like I look at this one strategy to do this is you build on your given premise. Like in my step 1 to step 2, I built on my given premise. I changed things around in a helpful way, right? I'm able to say these parts equal these parts right here. But then I can't really say anything else because, right, you're looking to build on your given premise, but then another step here, and people in my 5th block definitely said this for sure. They said another thing you can do is you can look at the conclusion. We got to look at yourself. What is it I'm trying to prove, right? What is it that I'm trying to prove here? I'm trying to prove measure of angle ABC equals measure of angle DEF, right? I'm trying to prove that these two wholes equal to each other. So the question I can ask you guys right now, and you should be asking yourself is, have I said anything about measure of angle ABC yet? Have I said anything about measure of angle DEF yet? Have I gotten those into the proof? I eventually have to say this, right? This is going to be my last step. Look at this here. They already put it in. Your last step is what you need to prove. So in order to get to that last step, you need to say something about measure of angle ABC. You need to get measure of angle DEF into the proof. So the question is here, what can I say about measure angle ABF? What's an observation I have? What's a rule? What's something we've studied so far? This is why you got to study the definitions, right? What do definitions allow you to do? What do postulates allow you to do? And what do these properties of equality and congruence allow you to do? So one statement, right, that you can say about, right, measure of angle ABC is that, well, it's just measure of angle 1 plus measure of angle 2 would equal that measure of angle ABC right there. Check it out. Measure of angle 1 plus measure of angle 2 equals measure of angle ABC. So oftentimes when you see two angle measurements added together and then they equal another angle measurement, what that's telling us is that this is a part plus part plus part. So part plus part, just two parts there, equal to whole assumption that's being made here, right? This plus this equals that. And the reason why we're allowed to do that is because people got together thousands of years ago and agreed, right? Agreed that you can add these two adjacent angles together and that would represent the same measurements, the measurements of these two adjacent angles together, and that would represent the measurement of the whole, right? Whole angle itself here. And that was an assumption, that was a postulate, that was a rule. And that is of course, the angle addition postulate. Okay, angle addition postulate, definitely go back and relook at that if you're struggling with it, practice with it. Segment addition postulate, right, works very similarly. That definitely comes up on this homework here too. Okay, so measure of angle 3 plus measure of angle 4, same deal, right? Measure of angle 3 plus measure of angle 4, that is part plus part equals whole, and that's also angle addition postulate. That's why they're lumped together with that semicolon there. Finally, we're going to get to the final step of the proof. We're going to be able to finish out proving this here. So we got to think now, how I'm actually saying this here. What am I doing? Well, check it out here. This is a little bit tricky, I think, for you guys at this point, I'd say. Like we have these two equations here. We have this top equation here, and we actually have two more down here. But anyways, we have these two statements, statement 2 and statement 3. I got kind of some important stuff in statement 3 because we did the angle addition postulate. That got me measure of angle ABC into the proof. It also got me measure of angle DEF. That's good because they're right down here. Check it out. DEF's right there. Measure of angle ABC is right there. So the question is, how do we get them to equal each other, right? To equal each other. Well, in step 2, right, we said this here. Look, measure of angle 1 plus measure of angle 2. And that is what's down here equal to measure of angle ABC. So what we're doing here is we're taking measure of angle ABC and we're replacing measure of angle 1 plus measure of angle 2 in equation number 2. And likewise, measure of angle 3 plus measure of angle 4, that equals measure of angle DEF. So we're replacing that over here, right? Replacing that over here. So the last step is what we're doing is we're taking two things that are equal to each other, and we're taking one of them and replacing the other into an equation, and that is called the substitution property of equality. Okay, I'm guessing some people will come in tomorrow with saying transitive as the reason, and that's okay at this point to be confusing those. That's fine too. Just quick reminders on those. The reason why this is substitution is what I just explained to you. I just explained to you exactly, almost verbatim, what the substitution property of equality is. But one way to tell the difference between transitive and substitution is that in substitution, you have 4 different statements here. So here, this is statement 1. This is statement 2, this is statement 3, this is statement 4. So you're talking about 4 things, and 2 of which are replacing the other 2 in another equation. Or one of which is just replacing one of the other in another equation. That's fine too. But the thing with transitive is that it's always, with transitive, it's only 3 things being said over 2 equations or 2 congruency statements, right? Because there's also transitive property of congruence, okay? All right, so that is number 11 right there. Hopefully got the answers. Again, I think if you were confused in this one, probably my explanation was like a little bit too detailed for you. So just keep it up, stay positive, and keep practicing. And fill in your answers tomorrow. And there'll be just plenty of practice here. You don't really need to get great at this proof stuff really until like chapter 3 or so, like chapter 3, chapter 4. So you have plenty of practice before then. All right, anyways, thanks for watching. I will see you guys tomorrow.